Today I want to talk to you guys about this concept of static equilibrium. Comes up a lot when we're talking about machines. First we have notice that we have a first class lever and we have two masses, and we'll call the one on the left twice as big as the one on the right. And if you look at the distances, the pink lines, we'll call the left one half as long as the one on the right. So I could recreate this in class. I could recreate a system that was the fulcrum is, imagine this fulcrum not in the middle, not like a seesaw, perfectly balanced situation, but I could fiddle with the distances and the masses and I could get them to balance. That is what we call static equilibrium. Simple as that. So what if I were to write an equal sign right here? And let's say equal, right? Because the left side and the right side are equal. And then what if we were to write an equation? Can I write an equation that states what we just said? I think we can. So we have a force that's basically going down, right? And those are the red masses on each side. And then they are a certain distance from the fulcrum, and that's what we call moment. Moment's a fancy word for rotation, and we'll talk about that more later. But what I care about is this right here. We have a force and a distance. So let's say that this mass weighed, I'm going to try and keep consistent with the colors of the picture. Let's say that it weighed 8 pounds, okay? And let's say that pink line was 1 foot away. So let me change my color again. And we're going to be using multiplication here. So we're going to say times, and then we're going to say 1 foot. Okay. And on the right-hand side, I said that the line was twice as long and the mass weighed half as much. So let's see, what if we went back to red and we said we were 4 pounds, right? Because we said that was half. Times, and I said it was twice as long, so let's say that that's 2 feet long. And I hope that you're understanding what I'm trying to say here. So of course 8 times 1 is 8, and that equals 4 times 2, that is also 8. That is what static equilibrium is, okay? We can achieve that balance even though the two sides aren't perfectly equal. Now what we can do with that is make that into an equation, and what we can do is take this and we can write it in such a way, has to do with our inputs and outputs that we talked about earlier. So let's say this left side was my input side, so I would have a force input, and I have a distance input, fin times din, equals fout, my output side, times dout. Fin times din equals fout times dout. Whenever you see a question that says, using static equilibrium equations, solve for whatever, this is a great equation to use. Oftentimes, you're given 3 of these 1, 2, 3, 4 things, and you just have to solve for that 4th one. So static equilibrium, fin times din equals fout times dout.